Hello guys, you're welcome to my channel. Today we want to consider why the sky is blue and why the clouds are white. As a matter of fact, not all the time the sky will appear blue. At times the sky appears red, at times it appears green, at times it appears yellow, at times it appears orange, even at times it appears black. In the night, the sky is black. But today we only want to talk about what? Why it appears what? Blue. Also, the clouds, at times the clouds appear what? Dark. Not all the time that they appear white. But today we want to consider why they appear white. Those are the two questions we are going to be looking into. And in the process, we might also explain some other things regarding what? The sky. Let's look into that. Now, when we talk about the blueness of the sky and the whiteness of the clouds, it's all about the presence of sunlight. So when we have the sunlight, when the sun appears, it appears in white color. So this is a white light coming from the sun. Now this white light is made up of what? Some colors. And those colors are colors of rainbow. The royal beef. Now, this white light now, if we pass it through a triangular prism, like this, it's going to split into its components. That is red, orange, yellow, green, blue, indigo, and violet. Now, these are the components of white light. Before we go into the explanation of why the sky is what? Blue, let us quickly try to understand something about light. Now, light is an example of electromagnetic wave. And when you talk about electromagnetic wave are those waves that electric fields and magnetic fields oscillate. When you have electric field and magnetic field oscillating with the speed of light, that is what we call what? An electromagnetic wave. That is, you have electric field like this. If I have this, if this is y-axis and this is a z-axis and this is a x-axis, if I have electric field that is oscillating in the y direction like this, and I have what? The magnetic field oscillating in the z direction. Sorry, don't mind my diagram. Okay, I have the electric field oscillating in the y direction but moving in the x direction. Now I have what? The magnetic field oscillating in the z what? In the z axis but moving in the x axis. Okay, so here is what? Magnetic field that is magnetic field in blue, and we have electric field in black. So these two fields, they oscillate perpendicular to each other. That is, at every 90 degrees, each field will do what? Would oscillate. So this is what we call an electromagnetic wave. Okay, when you now talk about electromagnetic wave, we describe electromagnetic wave or wave in general with two things, and that is frequency, wavelengths, okay, wavelengths and frequency. So when you talk about wavelength, what is wavelength? Wavelength is the distance between what? One adjacent crest to the other, or you say the distance between one adjacent trough to the other. That is what we call wavelength. And frequency is the number of oscillation per second. That is the number of cycles that a wave made per second is what we call frequency. For you to see what I'm saying clearly, let me draw a diagram for that. If I have a wave profile like this, and I have that a wave is oscillating in this direction, this is a crest, the maximum displacement upward. And this is a trough, the maximum displacement downward. And the maximum displacement of this wave is what we call amplitude, either downward or upward. Okay? Now the distance between the crest of the wave is what we call wavelength, or the distance between the trough. We call it what? Wavelength. And when you say frequency, this is what? Half circle, and this is complete oscillation. So when you talk about the number of such oscillation that this particular wave completes in 1 second, you're talking about frequency. Are we together? Now, we are going to explain these two for an electromagnetic radiation. Now, when you talk about electromagnetic radiation, we have what we call electromagnetic spectrum. And what is electromagnetic spectrum? Electromagnetic spectrum is the arrangement of the frequency of the electromagnetic radiations. So that is the range of the frequency of electromagnetic radiation is what we call what? Electromagnetic spectrum. Now, if you look at all this, the Röntgen, these are visible lights. Now, in the spectrum, let's say these are the spectrums now. If this is the visible light, here we have the red, the yellow, the green, the blue, the indigo, and the violet. Are we together? Then we have what? Here we have the ultraviolet, we have the X-ray, and we have the gamma ray. Here we have the infrared, okay? Infrared, microwave, radio wave, visible light, ultraviolet, X-ray, and gamma ray. These are electromagnetic spectrum. I want you to understand something about the spectrum. You know, the other time I talk about what? Wavelength and frequency. Now, let me explain wavelength and frequency on this. Now, if this is electromagnetic spectrum, as you move, this visible light is the only thing that is visible to human eye when it comes to these radiations. Every other radiations here is not visible except the visible light. And when you talk about the visible light, we have the Röntgen to be in that spectrum. That is, they are in the spectrum of what? Visible light. Now, if you move towards what? The right hand side of the visible light, the frequency is increasing. That is, gamma ray would have the highest frequency. And when you move towards what? The left of the visible light, you have the frequency reducing. That is, radio wave will have the least frequency. Now, as you also move to the right of the visible light, the wavelength is decreasing. Hence, the gamma ray will have the shortest wavelength. And as you move towards what? The left-hand side of the visible light, you have what? The wavelength increasing. Hence, radio wave will have the highest wavelength. We use radio wave in radio station, radar, and also in Wi-Fi. Then, when you talk about what? The microwave, we make use of it in cooking and also in our cell phones. When you talk about what? The infrared, we make use of it in our what? In our lamps and also our TV remote. And when you talk about the visible light, it's something that is visible, we can see it, and we use it for different sort of things visually. Okay, like the snoperscope, your phone camera, and the likes. And when you talk about what? The ultraviolet, we make use of this in black light. And when you talk about X-ray, you use X-ray in medicine. And when you talk about the gamma ray, we make use of gamma ray in nuclear what? Energy. Are we together? Now we know the usage of all this electromagnetic radiation. These are some of the uses. Like I mentioned, just one uses for ultraviolet. Ultraviolet can also be used in what? Or in sterilizing. We use ultraviolet in sterilizing. We also use gamma radiation also in sterilizing. It's not taken out. So they have a lot of usage. I only mentioned few about what we use them for, because that is not the aim of this class. Is that taken out? Now, we have understand that when we move like this, the frequency will increase, but the wavelength will decrease. But if you come down to this place, you will see that this is visible light. The next thing in the visible light is red. Hence, the wavelength of red light is greater than any other one in this spectrum. So, this one, the red light, has the highest what? Wavelength. And as it has highest wavelength, what will happen to its frequency class? The frequency is said to be what? To be the least. Is that taken up? Because the higher the frequency, the lower what? The lower the wavelength. And the higher the wavelength, the lower the frequency. Now I will ask you, and I would like you to understand that they all have the same speed. They are all moving with the speed of light, which is 3 times 10 raised to power 8 meters per second. That is the speed of all electromagnetic radiations. Are we together? Now, it shows that the violet will have the highest frequency because it's the one with the least wavelength. Now, either the orange, the yellow, the indigo, and the violet, you can only get them with a mixture of colors. When you mix 2 colors together, that is when you can start forming orbits. Hence, for this video, we are going to consider just 3 colors: the red, the green, and the blue, in order for us to explain why the sky is blue and why the cloud is white. Now, having to understand all of this, let's quickly look at something. What happens when the frequency of a body is small, and what happens when the frequency of a body is very high? Now, we all know that when a body has a very high wavelength, the frequency tends to be small. Hence, if I will have what? A red light. Okay, let me use red marker for that. Okay, if I will have a red light, the waves tends to be like this. You can see that the wavelength, this is the crest and this is the crest. You can see that the distance is quite large. Now, the other primary color we have to consider here is green. And if you look at the wavelength of the green, is quite shorter than that of the red. Hence, the green tends to oscillate like this. You can see now we have more oscillation compared to that of red. So if you look at it, the wavelength is short compared to that of red. And the last one, which wavelength is very, very small compared to that of red or that of blue, is going to have the highest frequency, and that is the blue light. And if you look at it now, it oscillates more than any of the wave. And if you look at its wavelength, it's very, very short. Now, what is now the effect of this whenever the sun rises? The effect of this whenever the sun rises is this. Let's take, for instance, that this is the atmosphere. I would like you to pay maximum attention so that you will be able to explain either you are a science student or not science student. Now, let's take, for instance, that this is the Earth surface. This is the Earth surface. The surface of the Earth. If this is the Earth surface, before the Earth surface, we have the atmosphere. Let me represent the atmosphere. The atmosphere is not empty. The atmosphere consists of some gas particles, dust, water, and so on like that. So let's say these are those particles. If this is the Earth's surface and these are the particles at the atmosphere, whenever the sun rises, this is the sun that rises in the morning. And now it's producing a white light that wants to shine on the atmosphere. The white light is to travel to the atmosphere, that is the Earth's surface rather. Now, the light is coming down to the Earth's surface from the sun, which we are also expecting in order for us to say the day is break. Now, as the light is coming down to the atmosphere, to the Earth's surface, it's going to pass through the atmosphere, right? Now, if the light will pass through the atmosphere, there are some particles that we have on the atmosphere. All these particles will cause these lights to split into its components. And you see red light, because of its high wavelength, is going to scale through these particles without crushing on any of them. And you see green lights crushing on them. When you see green light, because of the wavelength of green light that is smaller than that of red, is going to collide with some of them, and it's also going to scatter a bit. It's going to scatter just a bit, then it goes. But the blue light, because the blue light is oscillating very slow, so it tends to encounter a lot of them. As it encounters a lot of them, it scatters. As it scatters most because of its what? Frequency that is very high, so it tends to oscillate more. It's just like you also, when you do something very hurry, you enter where you don't want to enter. Take for instance, you are going to the assembly ground now. As you're going to the assembly ground, you are running. You hit your friend push you back, you get back to another seat, you stand up again to rush out, you hit something else. So when you tend to move very faster, you meet yourself where you are not going to, and you want to come out of the place. And that's the same thing that happens to what? The blue light. As it encounters different particles, it tends to scatter and scatter and scatter, and that is why it dominates the sky. So that's the reason why the sky appears what? Blue, because what? The blue light is the one that scattered most out of the three what? The three colors. Now, as the Earth's what? Keep moving, the sun is still shining to come down to the Earth's surface. Now, you are the observer, you are looking at the sky, isn't it? And the Earth keep on rotating. As the Earth keep on rotating, we have this. Okay, as the Earth keep rotating, let me clean this diagram for a better understanding of what I'm trying to explain. As the Earth keep rotating, like this is the Earth's surface. As the Earth keep rotating, we still have those particles in the atmosphere. They never leave the atmosphere. So as the Earth is rotating, the blue light continues scattering. As the Earth is rotating, what happened? The blue light continue what? Scattering. As it's scattering, we don't have what? Blue light in this direction again. We are now having what? A red light left over. Because what? The sunrise is already setting down to the what? Down to this aspect. And if you look at it, the Earth has rotated away from this place. So this portion of the sky keep on what? Retaining the blue light, because the blue light still continue what? Scattering. And you see all these parts appearing what? Appearing red. And that is why you see the sun appearing red during the sunset, because what? The blue light has extremely scattered. Then we have left the red light. Are we together? Okay, if that should be the case, let's quickly move into why the clouds are white. Now, when you talk about the clouds, just like we have this, the clouds now contain some water. The clouds does what? Contain some droplet of water. Now, the droplet of the water in the sky is heavy, such that even red light, despite its high wavelength, cannot what? Do without crushing on those what? On those small droplet of water. As the light crush on the small droplet of the water, the green light will also scatter, the red light will also scatter, including the blue light. So when the three colors scatters, they comes together again, and you should know or remember that red plus green plus blue will give us what? White. Are we together? And that is what we call the complementary color that we had up to give us what? White. So if you look at this now, when this scatter and this scatter and this scatter, they mix together to give us white, and that is why you see the clouds white. Okay, let's quickly see a beautiful experiment to see what we are trying to explain about what? The blue and the what? Whiteness of the sky. Okay guys, let's quickly now recall what we have been saying since morning, that when the light is from the sun coming down to the Earth's surface, pass through the atmosphere, the blue light starts to scatter because it encounters the particles, and when it passes through the cloud, because the cloud is made up of water, the whole of the color component is set to scatter, and the cloud will appear white.